Hi everyone. So here is the second recording of this lesson which I did and uploaded to YouTube, and then there was no sound, so I had to go through many troubles and again do it here. So one more time. So this lesson is review number 2. That's factoring. So factoring, like you are factor a number, you break the number to different, so to just prime numbers. For example, I can say, for example, 12 is, let's say 12 is, so maybe I can change the color. 12 is 4 power, so 4 times 3, and then yes, that's one factor, but it's not really just fully factored. Fully factored means to prime numbers. Okay, so I continue until I cannot continue. Okay, so that's fully factored. So 2 squared times 3, and that's for numbers. Okay, so now we want to do for polynomial. So for polynomial, you have x, y, so you have different variables, numbers all together, terms, addition. So you want to do the so factoring, like you have several or several brackets in multiplication, and each of them are simplified polynomials. Okay, so for example, I can show you here. So here you have 2 terms. Both of them are just in addition. That's just algebraic expression. So yes, but you want to, so just for example, you see a is in common, you factor a, and then you see a like a number times a bracket. So that's factored of this algebraic expression. Okay, so that expression is factored. Okay, so for numbers is not that challenging, because you use your calculator, you divide by 2, again divide by 2, then you divide by 3, you divide by 5. So you divide by prime numbers when you want to factor a number. But when you want to factor a polynomial, so you have to know some strategies to do that. The first strategy is you factor what is in common. What is in common? So you see what is in common, you factor. Oh, okay, here a is common. Here 4k is common. That's in common for all terms. So when you see something is in common, so for example here, yes, I see 8, I see 6. But 8 is not in common because 8 is not in all terms. I have to see what is in all terms. 2 is in all terms, x is in all terms, y is in all terms. Because 2 is here, x is here, y is here. Okay, so I factor. So this is 4y squared minus 3xy plus x squared, right? So 1 second, I just have to just have to check something. Okay, so that's the answer here. How about here? Okay, so what I see in common is so let me see. I see 2 is in common, and a is in common, and x is in common, but b is not in common. Okay, so b is 2b. Okay, so I have 2b plus 3ax plus 4. Yes, so now I continue. Okay, so you see this one, and I asked you to factor. So I see many students, they try to do least common denominator, they try to collect them all in one fraction. You don't need, okay? Just pay attention what you see in common. What you see in common is this. Okay, what is it saying from the first term? 3. What is it saying from the second term? Is this one. And what is it saying from this? Is this one. From the third one is this one. Okay, so you don't need to go through a lot of trouble to find least common denominator, to make it one fraction. You don't need. What you see in common, you can factor. Okay, so here the next part, I would like to talk about difference square factoring. Difference square is so just like this. Okay, so when I see a squared minus b squared, it is a minus b multiple a plus b. Okay, I need to mention other formulas for you just to have your attention to other questions, other types. Okay, so if I have a squared plus b squared, okay, I cannot factor that. That stays. I cannot factor. If I have a power 4 minus b power 4, I can factor, yes, to this, and then I can continue to factor to this. But this part stays. I cannot factor. If I have a power 4, I can write it here maybe. Okay, so I have a power 4 plus b power 4. That's a power 4 plus b power 4. I cannot factor this. I want to have your attention here, although we do not use and we do not go to so many questions on this type. So this one, which is a cubed minus b cubed, okay, a student, they always mix it with a squared and power 4, but it's not the same. I want to have your attention, okay, although you don't see so many questions of that. Okay, this is factorable to this. And how about this one? When I have plus, can I say like a squared plus b squared, like a cube, sorry, like a power 4 plus b power 4? Can I say like this and like this? This is not factorable. No, power 3 is odd number and it's different. I can factor to this. Okay, so I want to have your attention here and I want you to know it. Okay, so here, so yes, these examples are done and these examples also are here. For this one and this one, no, I cannot factor, but for this one, yes, it's y minus y squared minus 4 multiple y squared plus 4, which is y minus 2 y plus 2 y squared plus 4. Okay, so for this part I can't continue, but for the first part, yes, so I continue when I can. Okay, so then I go here. Okay, so these examples, let's do them. Okay, so it's 2x minus 3y multiple 2x plus 3y. It is 3ab minus 2c squared multiple 3ab plus 2c squared. Okay, so this is 11a minus 6b squared multiple 11a plus 6b squared. Right? Yeah, so yes, okay, so far so good. Yeah, so we can't continue here. Okay, so simple trinomials, so simple trinomial method. See, I really don't like, although sometimes I use these terms, but I don't want to say simple, complicated, because students they believe, oh, maybe that's simple and that's very hard, I cannot understand it. No, I would say just more work. Okay, so one of them less work, one of them more work, but it's not hard. Okay, so if I have something like this, which is a quadratic, okay, so you have x squared, okay, you have x, you have a number, you have coefficients beside them, a, b, c. So we want to know how to factor. We have two methods. One of them is when I have a equal 1, one of them is when I have a another number, it's not 1. Okay, what should I do? Okay, so here, okay, here, if I have a equal 1, it has less work. Okay, so I have to look for two numbers. If I multiply them is 15, if I add them is 8. Oh, okay, 15. Okay, so 15 equal 1 multiple 15. No, this is not the answer, because when I add 1 and 15, it's 16. Okay. So 15 times 1. No, it doesn't work. So multiplication is commutative. So yes, I can change the order, but it doesn't help me. Okay, so how about 15 equal 3 times 5? Oh yes, 3 plus 5 is 8. So I'm done. Okay, look at here. When you find the number, one of them goes here, one of them goes here, and then you are done. Okay, so let's do the answer here. So here I am looking for two numbers. If I multiply them 2, if I add them 2, if I multiply them minus 15. Oh, okay, minus 15. 15 multiple minus 1. It doesn't help, because when I add, it's 14. Minus 15 multiple 1. No, it's minus 14. Okay, so minus 5 times 3. No, it's minus 2. I want 2. Oh, okay. So 5 times minus 3. Oh, yes, this is the answer. I stop. Okay, so it is m plus 5 times m minus 3. I said x there because I see x. Here I see m, so I use m. Whatever variable I see, I use that. So when I look for two numbers and I find them, one of them goes in the first bracket, the other one goes to the second bracket. Okay, look at this. Here, I'm looking for two numbers. If I multiply them, is this. If I add them, is this. Yes, I can find it. It's here. And then this is the answer. Okay, so how about this one? Again, the same. If I add them, is this. If I multiply them, is this. Okay, yes, I can find it. This is here. Okay, so how about if A is not 1? A is not 1. It says a complex. I don't like it. Oops, what happened? Okay, I don't like it. I just want to say more work. It needs more work. Okay, so I show you on my example. I just show you on one example. Okay, see, this is not 1. I am looking for two numbers. Okay, if I multiply them, is 3 times 2, which is A, C. Okay, look at this. I write it here. C, it is ax squared plus bx plus c. I am looking for two numbers. If I multiply them, is AC. If I add them, is B. Okay, this is my number, 6 and 1. I do not touch the one with x squared. I do not touch the last one, which is just a number. I just rewrite 7x. I rewrite it to 6x plus 1x. And then from each two, I group them. From group number 1, which is number 1 and 2, I factor what I see in common. From group number 2, I factor what I see in common. And then I factor what is in common for brackets. Let's do it here. Do it for this example. Okay? For this. Okay. I am looking for two numbers. When I multiply them is 12, which is this. When I add them is minus 13. Minus 12 and minus 1. Oh, yes. Okay, so I do not touch the one with x squared. I do not touch the I do not touch 3, but I write minus 12x minus 1x. So instead of minus 13x, I just write minus 12 minus 1. Okay, remember, you need x for both of them, because sometimes I see a student, they make mistake. They write minus 13x equal minus 12x minus 1. They forget they need x for both of them. Okay, you are not changing your question, you are just rewriting it. Okay, so 4x is factored x minus 3, and here 1 is factored 8 minus 3. Why? Because I want x minus 3 to be in common. Okay, x minus 3 factored. From the first I have this, from second I have this. Okay, how about for this one? Oh, okay, A is not 1, but I see when I factor 3, I have equal 1. Oh, Okay, common factoring. 3 is in common. So it is this. Perfect. That's good. So if I can, I factor them. Okay, if I can, I factor something from all of them. And then, oh, okay, yes, I go to the less work one, not more challenging one. Okay, that is more work. Okay, I just want to check something here. Just 1 second. Okay. Yeah. Just 1 second here. Yes. Yeah. Just wanted to see if I missed something. And no, okay. So now I go here. Okay, so I factor 3 here. Oh, okay, so I am looking for two numbers. If I multiple is 7. If I multiple is 21. If I add, it's minus 10, which is minus 3 and minus 7. That's 3 multiple b minus 3 times b minus 7. Okay? Good. So now I continue here. Okay, so I am looking for, okay, can I factor 5? No. So the first thing I remember and I want to do is common factoring. No, I cannot factor 5 from all terms. Okay, so, okay, so I'm looking for two numbers. If I multiply them, 15. If I add them, is minus 8. Okay? Oh, okay, so minus 3 and minus 5. Okay, I do not touch the first one. I just touch this. I just touch this. And I do this. Okay, so I factor from the first one, I factor a. From this one, I factor minus 1. Now I factor 5a minus 3. Okay, good. So how about the next? Okay, I am looking for two numbers. If I multiply them, 7 times 2, 7 times 6. If I add them, is 23. Okay, so that is 21 and 2. Yes. Okay, so 7x squared plus 21x plus 2x plus 6. Now I factor 7x, x plus 3, and 2x plus 3. And then I factor x plus 3 times 7x plus 2. Okay? Okay, so these are just examples that I added to the lesson. Okay, so these are just added for you. And you can do them. These are very good practice. They are all good exercise for your brain. You really need to be good in and just be hardworking in algebra to be fine in this course. Okay. Now, as I see here, okay, so let me see what's wrong here. Okay, maybe I have to make it small. Okay, yes, I tell you to factor this one. Okay, I tell you to factor this one, and then you would say, oh, that's x power 6. Come on, I don't know. Okay, I say, okay, pay attention. If you see something power 2 and the same thing power 1, that's a quadratic. Oh, okay. Okay, so I can change x power 3 to w. Oh, okay, so this is 3w squared minus 5w minus 2. Okay? And then, yes. and then I can factor. When I factor, I am looking for two numbers. If I multiply them -6, if I add them -5, so -6 and 1. Okay, so I do not touch the first. I just write this plus this. Okay, instead of -5w, I do -6w plus w. Okay, so now I factor 3w, w minus 2 plus w minus 2. And w minus 2 I factor, which is 3w plus 1. Okay, that's great. Okay, so now I continue. Oh, okay, I see power 4, but I see this is x plus 3 squared, minus this minus 10. Okay, let's do it. So I do x plus 3 squared equal w. Okay, w squared minus 3w minus 10. Oh, okay, so it is w minus 5 multiple w plus 2, and w is x plus 3 squared minus 5 and x plus 3 squared plus 2. Okay, can I continue after this? No. When I was a student, we had to continue here. We had to say it is x plus 3 minus radical 5 because that one of them is squared and the other one is x plus 3 plus radical 5. Okay, but you don't do it here. No, here no. Okay, so you stop. But if you have x plus 3 squared minus 25, yes, you can factor. You can continue. Okay, so I can write it here. If you have x plus 3 squared minus 25, for example, okay, then you can say, okay, this is x plus 3 minus 5, and that's x plus 3 plus 5, which is x minus 2 times x plus 8. Okay, if so, how about here? Okay, so I just make a line here. Okay, so that's x power 2p squared plus 7x power 2p plus 10. Okay, okay, x plus 2p is w, so w squared plus 7w plus 10. Okay, so w plus 2 times w plus 5. Okay, and then don't forget, I didn't give you w from beginning, so you have to go back. Okay, so it is x power 2p plus 2 times x power 2p plus 5. Yes. Okay, so yes, here I want to check something, and that's that. Yes, yeah. Okay, how about if you have top and bottom, if you have just fractional expressions, what do? Okay, doesn't matter, I just factor top, I just factor bottom, and I simplify. But I have to mention something mathematically. Mathematically, I'm not able to cancel this and this. Oops. I hope this helps me to just teach, you know. Just jumps here and there. Okay, this is crazy. Okay, so Yeah. Mathematically, I cannot cancel this and this. See, I factor top, I factor bottom. Okay, so what happened? I factor top, I factor bottom, and then I say, okay, common factoring, and then just factor trinomials, and then I see this is in common, I factor. I cannot factor this. How do I cancel this? I can factor, but how do I cancel? I'm talking about cancellation. Cancellation means you are dividing top and bottom with b minus 5. When you say you are cancelling, means you are dividing top and bottom with b minus 5. You have to make sure b minus 5 is not 0. Otherwise, you cannot divide top and bottom with something equals 0 because that's undefined. So I have to mention that. I have to mention denominator is not 0 because then b is not 5, and then I can cancel. I can divide top and bottom with b minus 5. And then I can cancel b minus 5 and b minus 5. So for all the fractional question, if I want to have the question correctly, I have to say the denominator is not 0. But it's not just your job. It has to be part of the question. Okay, so you don't need to be worried about that. Okay, so what you do is you factor top, factor bottom, cancel what you see in common, and at the end just write the simplified answer. If you are very good in math, you can say, okay, if you want to be very careful, you can say b is not minus 1 because then the denominator is 0, and so that's not defined. But again, you don't do it, I don't reduce mark because it's not part of your job. Okay, see, factor top, factor bottom, and then cancel what is in common. Oh, okay, see, I can factor, okay, so factor here. So this is a plus 7 times 2a plus 3 for top. A plus 7 times 3a plus 5. Okay, so do I see something in common? I have to say denominator is not 0, but it has to be part of the question, not your fault. Okay, so this and this cancel. The answer is 2a plus 3 over 3a plus 5. I have to say a is not minus 5 over 3 because denominator cannot be 0. Okay, so I don't do so many questions of this. First of all, this is review. Second of all, that's just factoring. Okay, we did questions of factoring. So you factor top, you factor bottom, and then just cancel. Okay, I just want to do this question here because I see division. If you see division in fractions, the one after division, you change it to multiplication and flip it. Okay, so x squared minus x minus 12 over 3x plus 9 the multiple x plus 5 divided by x plus 5 times x minus 4. Okay, so can I factor? Yeah. Can I factor this one? Yes. That's x minus 4 times x plus 3. Can I factor this? Yes. 3 times x plus 3. Remember, you factor all top, bottom of all of them. But if you see division sign, you have to flip the other. So change division to multiplication and flip the one after division. Okay, so now I cancel this and this. Now I cancel this and this. Now I cancel this and this. And the result is 1 over 3. Okay, so we are done with this lesson. For review number 2, that's factoring. So you have to be careful. Factoring has many other strategies and methods. We don't go to too much details. So you have to be careful with common factoring, what is in common, and then difference square power 2, power 4, and then trinomials. A is 1, less work. A is not 1, more work. Thank you.